Oh, good. All right, sure. Uh, Good morning, Anna. We're still waiting for people, but I'm trying to get the audio working.
Yep, sounds good. The audio's clear.
Okay, excellent. Thank you for confirming.
Yeah,
I
of course.
think we're good. So you don't have to join the Zoom. It's just we're doing like in the classroom, like it's a telepresence. So some students are doing Zoom, some are coming in classroom, and some are, I think, even doing like asynchronous. But
Mhm. Yeah,
so
I'll be here for the first class and see what's better.
okay, sounds good.
But thank you for making it an option. I really appreciate it.
Yeah, you're welcome. We gotta go to screen. Mhm. Morning. Oh, don't do that. Okay. Morning. Thank you for addressing. So, that's all. Anything? Or did you go back to work there out there? Oh, it's cool. Yeah. Good with them.
Yes.
Morning.
I just wanted to.
Oh, yeah.
I was the one that emailed you, just wanted to.
Oh,
quick
okay. What's your name?
Introduce myself, Isaiah.
Isaiah. Oh, yeah,
Had
yeah.
to leave a little early.
Gotcha.
At like
You got it.
29, just wanted to introduce myself.
Nice to meet you. You got a soccer match?
Yes,
Okay, good luck with that.
thank you.
But thanks for letting me know. Oh, 8:30. Well, let's give it a few minutes because,
Yeah,
yes.
I'm curious on what is telepresence? What does that mean?
It's just a term for the course being taught like live, but also remotely. Like,
Oh, okay.
so it means it could be in the classroom, or via Zoom.
Oh, so there's a Zoom, okay.
Yeah, so there's a Zoom, concurrently going at the same time for students who can't attend live.
Okay, cool. Yeah, I was confused when I saw telepresence. I didn't really know what that
I
was.
had to look it up too, honestly. Yes.
Do we still get full points like attendance wise for being online too?
Yeah, I'm trying to figure out how to keep track of that, but yeah.
It's like an option type of thing.
Yeah, you have the option. I'd encourage you to come to class if you can, but, you do have the option.
Okay.
I don't know if I can commute, but,
Has it always been a Saturday morning class, this one?
uh, I don't, as far as I can remember, but, I think I've only taught it Saturday mornings, but last time I taught it, it was just in person and not telepresence.
Okay.
Um. Good morning, Adrian. All right, let's give it a few more minutes because I think there's 13 students, so 2, 3, 4, 6, 7, 8, and one person could go through. You're all here for multivariate statistical analysis, right? Okay. Yeah, and for some of you, it's MDA 502, and some it's 402. I think 402 is the undergrad version. Is that right? That's my understanding. Okay. How many of you are undergrads?
Yeah.
Is it,
Yeah.
okay, is it 402 for you?
I'm trying to see.
I'm undergraduate, I'm doing my master's, like a 4+1 type of thing.
Yeah, I'm
Gotcha.
interested.
Yeah.
Okay, good morning.
It still says 502 for.
502? Oh, okay, interesting. Yeah, I don't know why it's a 402, but maybe it's,
But yeah, for the other master's class, I'm thinking, yeah, it says 401.
401,
So, yeah.
okay. There's two CRNs, I don't know who's in who's, or who's in which. Okay. All right, I guess we can go ahead and get started. It's 8:33. I think the class starts at 8. I actually thought it started at 8:35, but it starts at 8:30. So just a minute to make sure, Anna and Adrian, you can hear me okay?
I can hear you good.
Okay, excellent. All right, so we've got almost quorum. I think there might be, oh, there we go. Good morning. A few more students that joined. So as I mentioned, so this is either MDA 502 or MDA 402, depending on your CRN. And this is multivariate statistical analysis. You all should have received an email from me a few days ago with the Zoom link and some other info. So everyone can access the, what's this called? B2, this website.
On D12.
Yeah, everyone can access the course website. Yeah. Okay, excellent. All right, and so, yeah, the way the class will work is, it's quote unquote telepresence. And that means that, depending on, well, I guess I'll do a Zoom link every time just because I want to have a recording and just make sure that you can catch up if you need to. So just to disclaimer this, so we're recording this class right now. So just note that it might take me 1 week to figure out the logistics, but I think I've got it down. And so what I'll do is record all the Zoom meetings and then make a link on just YouTube so you can watch it if you need to. So you should be able to access all the recordings. I can't promise the first one will go well just because I'm trying to figure out. I'm not super used to Zoom. I use Microsoft Teams every day for my full-time job, so I think I'll get the Zoom down pretty well. But just disclaimer, if something goes wrong the first week, I'll figure it out. But I think we're good. So we're recording, and I'll make the option available for you to join the Zoom. I would encourage you all to come to class if you can, but I know realistically not everyone's going to come to class every day. But if you can, try to come. If you cannot, join the Zoom. And then if for some reason you have a soccer match and you absolutely can't join, then the recording will be available to catch up at a later time. Okay, so any questions on, and I do have a small attendance portion. Maybe I'll probably take attendance just so I can get familiar with all of you, or maybe we'll do quick intros. I'm gonna be very lenient on attendance, so I'll just, as long as well, if you come to class, you get full points. Via Zoom or in the classroom. And then if some of the students have to miss and catch up, as long as you confirm that you have caught up on the class recording and done the work, then that'll be fine. So it'll just take a bit of research for me to give you credit if you miss a class, but you'll still get full credit as long as you catch up. Okay, so any questions on logistics? Yeah, okay, cool. We'll get to the syllabus. There is a software for this course. I don't, have you all used JMP before, like SAS JMP? Okay, so there's a student version which is free. I'll show you how to do it today. There's a link in the syllabus, or you can just search for it too. So you just basically put in your Laverne academic credentials and it should give you access. If for some reason it takes a day or two to get up and running, no big deal. We do have an assignment that's due next Saturday. If for some reason I see there's a lot of tech issues and students can't access to do the homework, there's an option to push both the first two assignments to be due in 2 weeks, but we'll see. So I'll try to get you started on the software. I can't, everyone has a laptop or everyone is gonna, okay. So I guess you're not required to bring your laptop, but I'd highly encourage it because we're gonna do a lot of analysis and computer work together. So if you do it along, you'll probably learn better, but if for some reason, you can't get the software. I've had some issues with students having like a work computer and getting permissions, so that might be a workaround, but I don't think it'll be too difficult to get the software. But we'll give you some leeway, so if you can't get it working today, don't panic, and if it's like week 4 and you don't have the software working, then you should probably panic, but I think it's okay to have some leeway. So normally the first class, there's some tech issues. Only issue is I think the tech support is closed on weekends, so I'll be your tech support today. But hopefully there's not huge issues, but if there are, I can always give you the number to IT and you can call them Monday or Tuesday. So this course used to have like a license to JMP. I think we've downgraded to just the student version, which is fine for this course, but just make a note that I think the license is for like a year. So if you want to continue using the software, then just make sure you talk with your do y'all have academic advisors or okay. Okay, so why don't I do a quick, I have a little, so this is my first time teaching this course on this website, but I've taught this course a number of times on Blackboard, which is pretty similar. I don't know if you'll use Blackboard before. But it's just it's another version of this D2L, but it's now this. So I think everything should be pretty smooth, but I have a little begin here section on the first website. There's some university info, some tech assistance. I did have a little welcome thing, so a little small, but I think you can see it. I don't know if I can see it, but okay, so why don't I introduce myself real quick. And then just so I can get to know you all briefly, we can do quick intros and we can go on from there. So we're taking MDA 502, some of you it's 402, but it's the same course, multivariate statistical analysis. So this is fall session 1 that goes for 8 weeks. I think a lot of you are either Master of Data Analytics or some of you taking this undergrads. Either way, it'll be the same course, so the grading will be the same for all of you. So I have my cell number here. So I'll get to. Normally I have another job from 8 to 5 every day in the week. So I'll normally not be checking my cell phone. You're welcome to text or call me if it's some kind of emergency or like if for some reason I haven't responded to your email. Just note that I probably won't answer or respond between the hours of 8 and 5, Monday through Friday. So if it's urgent, you can use that number. It's my personal cell. I'm not gonna tell you not to use my cell if you need to, but just it's there if you need, if you're I don't know, you're stuck in, well, I don't want to tell you to text or call when you're stuck in traffic, but if there's an issue and you're going to be late to class or you need something, you're welcome to use that. But otherwise, my Laverne emails, I usually check that not throughout the day, but like I said, I'll respond in the morning or at night depending on my other hours. Okay. So full name is James Joseph Hoffman. I go by Jake, so you're welcome to call me that. So I have actually I don't teach here full time anymore, but I have been teaching since 2016. So I actually believe I started in the fall of 2016. So this would look at Laverne. And so this would be about my 10-year anniversary, if you will, here. So this is, I've taught a number of courses here, close to 100 at this point. I only teach maybe one or two classes a year these days because I have another full-time job, but I do look forward to teaching when I get the chance, and so this is kind of my you know 10-year anniversary here. So if you have any questions on other, I have a large background in economics. I've taught in business, data analytics, statistics, other things in that area. So if you're interested in other areas or courses, I might not be up on all the courses, but I can point you in the right direction if you're looking to boost your skills, or you want to choose between two classes or something like that. Okay, so I have a PhD in econ from Claremont Graduate University, which is just down the road, about 5-10 minute, 15-minute drive. My research was in renewable energy and particularly in California. Since October 23, so about 3 years, I have been working full-time at Southern California Edison as an advisor, senior advisor on we're an evaluation, measurement, and verification team. So that means we do a lot of advising on analysis and modeling, and actually lots of compliance. And it's a utility and it's a monopoly, so there's a lot of rules with California, but it's a very engaging and challenging job, and I really enjoy doing it. So that's what I do 40 plus hours a week during the week. I work with a lot of or I have a kind of a small team built up of PhD economists and also very smart engineers. So it's a nice mix of what you need for the electricity sector. So if you have any questions about electricity or Edison, a lot of our customers' data and programs, a lot of stuff is confidential, but I'm happy to answer any questions in that area. And if you're I don't know what your career paths are, but if you are interested at Edison, I'm happy to facilitate that. Or I'm not a hiring manager, but we're always looking for good employees for lots of different jobs. So just note that I do have some resources at Edison and lots of background in electricity if you're interested. Okay, so that's about it for myself. This will be an 8-week course. This is the first class. It's going to go for 8 weeks. We'll meet every Saturday. Depending on the class, I don't know if we'll use the full three hours or so, or 3.5 hours. I do plan to be here at 8:30, so I'll try to start right around then. So we can get things going at 8:30, 8:35 at the latest, and then depending on how much we have to cover, it might go the full time. It probably won't today, but just I'll reserve it there. But if I cover everything and it seems like you're getting a little exhausted, then we don't have to use the full time. But okay. I've got some. Good morning. Okay, I got some other resources available on we'll look at the syllabus in a second. There's some free textbooks. There's a lot of other, I'm showing you now that the student version or the learner version. I have a bunch of other things that I can make visible, but I don't want to overwhelm you with lots of things. So things will start popping up on the website, but I think you have enough to go by for now. But I'll let you know if there's something important or you need to check something on the website. But I don't know if you get notifications or whatnot, but there'll be lots of things appearing on the webpage. And I haven't, like I said, I haven't used this D2L course, D2L platform for this course before. I'm going to try to use this assignment section. Here's our first assignment, and I don't know exactly how this works, but I think you can submit your assignments here, and but we'll see how that goes. So have you used the assignment feature before? It works. You just upload things and okay. All right, so that should be fine. Worst case, there's email, but I think we should be good with that. Okay, So I'll give you a little more, preview of the course website and the syllabus. Why don't we do some quick intros first? And then, I'll try to remember if you go by something that's not your, Laverne academic name, let me know. And I can try to make a note of it when I do attendance. So why don't we just go, why don't we start with you, if you don't mind?
Yeah.
If you're right there, and then we'll just kind of snake around, and we'll do, Anna and Adrian after we do the class.
Okay. Hey, hello, everybody. My name is Nolan Dorian. Currently a bachelor's student. I'm doing a business administration. I'm looking to do my master's in data.
Excellent, thank you.
My name is Noah. I'm a graduate student. I should probably master's last spring. Data analytics and yeah.
Excellent, thank you.
My name is Emily. I'm doing my master's degree, and I got my bachelor degree back in 2015.
Excellent, thank you.
My name is Linda. I got my bachelor degree in 2019. Now I'm doing a master on data analytics.
Hi guys, my name is Caitlin. I just got my bachelor's degree in computer science with a concentration in AI. And I'm getting my master's degree in analytics.
Excellent,
Hi, my name is Kirsten. I'm still getting my undergrad in computer science, then getting my master's in data.
Hi, my name is Isaiah. I just got my undergrad in statistics and data science, and then also the master's in data analysis. So name's Trey. I'm an undergraduate student in business administration. I'm trying to get my master's in data analytics.
excellent,
Hello, my name is Bo Yu. I got my graduate in China and just got my MBA degree this spring, and this is my second master's degree.
excellent,
I am Shane. I got my bachelor's in data science last year, and now doing the data analytics here.
excellent. All right, so we just had intros from, I guess, 10 students in the course. Actually, everyone, there's only one student not either live or here, so that's great. I don't know if you heard all the other students, but Anna, do you want to introduce yourself?
Oops. So my name's Anna. I recently just graduated with my degree in psychology, actually from U of U as well. So I'm excited to be back, and it's pretty different, but I'm also curious how I can mix psychology with business and data analytics. So yeah, that's my background.
Thank you, Anna. Adrian, you want to do a quick intro?
Yeah, how's it going, class? My name is Adrian. I have my undergrad in business admin, got it at ULV as well, and I'm getting my master's in data analytics. Happy to be here.
Excellent. All right, thank you. I'll keep my video off normally, but just nice to meet you all that are not here. Okay, all right, we did intros. So why don't we start with the syllabus? Unless there's any other questions. Yeah, okay. Let's do that, yes.
Anyone else who's we have to start JNT, right?
Yep.
It's taking like super long time for anyone else in here, which is.
I haven't tried yet.
Yeah, good, that's a good point, and I'm glad you already tried doing that, so I'll.
Download or like getting
The balance.
either download it.
The donor, okay. Yeah, if you've done that already, great. If not, I'll give you some time to do it here and see if I can troubleshoot a bit, but yeah, I don't. Mine, it didn't take a long time to download. It took me a while to get, like, they had like to look at my case a few times. Probably because I'm educate or a professor and not a student, but I don't know. Hopefully it's pretty smooth, but it shouldn't take more than a few days to get figured out. All right, so syllabus. And just, let's see, I kind of like if you click on the content, it shows kind of a table of contents. So as of now, I don't have a whole lot on here. And we have some week 1 stuff. There's some kind of key terms, class exercises that we'll get to in homework in a bit. There's some lab notes you can refer to if you want to look at some other examples. Some of the homeworks are kind of a mashup of lab notes, but there's some other exercises here. This one, if it works. Actually, this is not the one I want to. This is another resource, but there's a better one. Let's see. So textbooks, learning library. Yeah, there's a couple free textbooks that, and some of them get a little advanced or techy, but I encourage you to take a look at some of the concepts there. This JMP learning library, I think is very useful. We'll use some of this today, but it's got a lot of key areas. If you click on these things, we'll do like this one today, but there's click on the term, there's like a little tutorial, there's a guide, and it'll walk you through key concepts. So I think there's some pretty useful things there. And once we get JMP up and running, there's a lot of sample databases that we can use to do analysis. So that makes it nice. Okay. Okay, so why don't we look at syllabus? Okay, I already went through my intro. I don't have a physical office here, but we can do either office hours if you need so in this classroom before or after, or I can set up a Zoom meeting to do a personal office hours, but I'm available for office hours. I just don't have a physical office here and nothing scheduled, but if you need additional assistance, please let me know. Or just want to request office hours. So we'll start at 8:30-ish. This goes to 11:45. I don't know if we'll use the full time every week. We'll do a quick break, maybe around 10 or so each time. I think that's a good breaking point. So you can take a look at the course description. You've probably already seen this, but we're going to do a lot of statistical analysis. I don't know if the prerequisite is required for all students anymore, but just as long as you have some statistical background and just some moderate computer skills, you should be fine. But things will get a little advanced, but we'll work our way through it. I don't think you'll get lost, but if you get a little behind, just let me know. But we'll try to do a lot of things together so we get the hang of it. All right, so we'll look at a lot of case studies. We're gonna look at a lot of different techniques. These are the 2 free textbooks. I'd encourage you to look at some key concepts, like if we learn something like regression and you want to bolster your learning on it, or some other areas, or we might have one day that I'm still figuring out the lesson plan. So if there's something still in the syllabus or the kind of course outline that you would like to learn, let me know. The question or the AI thing, I'm not haven't really incorporated in this class yet, except for it should be doing the AI Zoom notes. We can use AI to essentially do Google searches and look for that. I'm more familiar with Copilot just because at Edison, that's a licensed AI. So does Laverne have a licensed AI that you use normally? Or is it just whatever you want to know?
I'm not sure.
Okay. Okay. Well, I'll see if there is, but if not, there's always just, yes. I said, do you have a licensed AI that live in?
I don't believe so.
No? Okay, you probably know if you do, yeah, okay. All right, so we'll use, moderate AI, but this course won't be very AI heavy just because I want to teach you more about the stats and the modeling. But we'll use it as if needed. So this is the course software. It's JNP student. Just let me see if this works. Yeah, so I'll get you started on this in a minute. It might take a minute. I don't know if it's going to be available for everyone today, but if it is, we can start using it. If not, I can do some examples and you can kind of catch up at your own pace, but I'll get you started and see if I can troubleshoot any issues today, but we'll try to get JMP student up and running today if possible, but again, I'm not sure if there's any logistical issues there. So we're gonna be using that a lot, pretty much every day, like all of our assignments and class exercises are gonna be through this. It's a really, I think it's a really useful software. It's very drop-down menu based as opposed to like, there's a lot of softwares like Python or R, which are more type in the command code base, but this is more lots of drop downs. So I think it's a pretty useful software. If you're not a student, it isn't free. So just note that you know, if you graduate and you want to use the software, you would either have to get it through your employer, which is preferred, or purchase it. But I think softwares like this are mostly either licensed to universities or to big companies. So, but I think it's pretty useful. And you know, definitely put this software and any skills you think you'll learn on your resume, on your LinkedIn, like this. Knowing these types of skills are very important. So just if there's anything that you think you can put in your resume, just start keeping a list and let me know if you have any questions on that. But a lot of things, a lot of keywords you learn in this class are going to be useful as key items on your resume. Okay, so we're going to have. I do just a simple, not percentage structure, just because I think it's a little bit easier. So it's a point sum. You'll start getting points as the course goes along, but just note that like you can't get the maximum of 100 until you get to the end. So it's just you do one assignment, you get 10 points and so on. So it's we have 4 regular JMP assignments, which are 10 points each. We'll start one today. We have 2 longer case analysis, which are more looking at a specific case and answering some research questions. Those are 15 points each. And then I'll have a take-home final, which I think is going to be the last day of the class. Let me see. Yeah, so we can modify this accordingly, but I just had, basically we have, 7 assignments and I just had 1 to each of the Saturdays. If, like I said, if for some reason the JMP software isn't cooperating, we can make the first assignment due in 2 weeks, but that'll give you 2 assignments in 1 week. But anyway, I'll be a little flexible when it first started because I want to make sure the software is working. And then we'll see if the final is a good day to have the last day of the class would be the final due. And we will do, I think sometimes I like to do like a portion of the final is little student presentations and part of a research project. So I think our last day would be, the take home part of the finals due, and then you'll have a little portion to do some stuff in class. Okay, right, so finals 25 points, we'll get into that later. And um, 5 points for attendance, so this is gonna be a pretty lenient 5 points as long as you come to class and participate. Even if you miss class, as long as you confirm that if you watch the recording and caught up, it should be fine, so you're gonna have to convince me you don't get the 5 points, but you know, if you stop coming to class at all or communicating, then I won't give you the 5 points, but it's gonna be a pretty easy 5 points to get. Okay, so we'll have a take-home final. We'll have those 2 case analysis, we'll have normal JMP assignments. And this is just, course policies, you can take a look at this stuff. I have a list of topics that will do a lot of these things, maybe not all, and maybe some additional things, but these are just some of the main topics that we'll start looking at. Just learning JMP, looking at some multivariate methods, MANOVAs. We'll start with regression and simple regression, multiple regression. We'll do some k-means clustering, which is very useful. And so don't be, scared if you see all these terms and don't know what they are. I'll explain them to you and we'll learn them as we go. And we might not learn every single one of these things, but this is a list of the general areas that we'd like to look at for this class, and we'll kind of take things accordingly. But this is a rough outline. We might add a few more things, but anyways, if you look at some of these terms and you're like, I don't know what that is, don't worry about it too much yet, but okay. And the last thing is pretty simple assignment dates. It just I had it so every Saturday starting next Saturday, you have an assignment due. Again, if there's issues with the software, we can push assignment 1, but if everything goes on track, we'll just keep it due next Saturday. Before someone asks like, what time is it due? I don't usually specify a due time, so just anytime on Saturday up to midnight is fine. I'm not going to check my email at midnight, but if you can use, I'm not a late worker, but if you are, if you do work at 11 o'clock, you're welcome to turn it in by end of day. But up to you. Okay. So I think that's the gist of the syllabus. Questions on the syllabus? Yeah. Yeah, everything sound good? Yeah. Okay. All right. So why don't we start looking at some, actually, before we do that, let's try to download the software, just to make sure that that's going. And so it might, I'll see how it works, but if you go to you can either go to the syllabus and click on this link. You can also just, I think, find it pretty easily if you go to Google and type in JMP student. There it is. So either one is fine. And then if you click on, everyone can find this part. Okay. And then if you click on get JMP for free, it's going to give you something like this. And then you've got to get started at my JMP. And then you're going to put in your, I actually don't know what it looks like to start with, but you start putting in your learning credentials, and there might be a few questions that should, start processing or downloading or giving you access. But why don't we try to do that real quick? If there's any immediate issues, just raise your hand, let me know, or if you can't even get to this section, let me know, but. Is everyone able to start doing this process? Yes? Okay. Yeah, good question. Oh, what Wi-Fi? Laverne. Yeah, it was not, well, I used the not Wi-Fi protected one, just, yeah. Yeah, it should be, yeah. It's the same one as your Laverne portal. I, I mean, honestly, I just had to change my password this morning because I didn't know mine, but. Yeah, so try to do the JMP student. And hopefully it downloads right now or gives you access or something, but if not, I can try to troubleshoot these. Has anybody got it going already? Yeah? Oh, nice, okay. Yeah. Sure. Oh, okay. Oh. So you're still on this would be registered, extend registered. I think you just do this, but if not, you can always. Yeah, just click on okay, so maybe you have to re-register. Unless you already have it, I mean, if you already have it, then that's not. Yeah, that should just be able to. What else? All right, so we're just downloading we're downloading the JMP student. FYI, Adrian and Anna. If you have any issues getting it up and running, let me know, but just take me a few minutes to get the software going.
Yeah, I think I finished the process, but I think we're gonna be waiting a while, a few days maybe for my account to get approved. But I'll keep you updated.
Okay, sounds good. Yeah. Okay. Anybody gets it going, let me know.
Who's your football team? I see it. Football.
Well, I'm a very big Detroit Lions fan. Yeah, so it's always almost our year.
Yeah, yeah, past few years.
We'll see, yeah. How about you?
I like the Ravens, yeah.
Yeah. Rams are good.
My job, I have 2-1 Sunday, so.
Oh, yeah. Already, that's early.
Yeah.
Are you from Detroit? I'm not from Detroit. My mother-in-law's whole family is from Detroit, but the main reason I'm a Lions fan is because actually I grew up a Rams fan. Much older than all you, and then they moved to St. Louis. And I was like, I'm not gonna move to a St. Louis team. And Barry Sanders is my favorite athlete, and so I'm just like, I'm gonna switch to the Lions just because of Barry Sanders. That's why. And I stuck with them. The Rams came back and I'm like, I lost it.
Yeah, we left once, yeah.
Yeah. But good to see they're back and doing well.
I'm gonna win it this year, I believe.
Are they the favorite now? Probably.
Yeah, and I'm not like Miles Garrett.
Yeah, that's not gonna. And Aaron Donald coming back. Right?
Yeah, hopefully, that'd be nice.
Yeah. And just let me show you what the looks like. So it should give you like a little, what's this called? Desktop shortcut. And if you open it, it's gonna look like this. It already gives you like a little tip of the day. But the main thing is so once it looks like this, then you know you've got it going. So give it a. So do we think we're getting close, or is it gonna be a while? Like, tickets,
I don't mind that.
huh?
I don't mind on that screen.
Oh, you got it?
The download is annoying. Pretty.
Okay, yeah, this, all right, so you're,
It's like,
okay, yeah, we'll give it a few more minutes then.
Professor, quick question.
Yeah,
I have a Mac and I downloaded the Mac version of it through the website, but now I'm not sure if you've seen this before. It's saying that when I select a destination where I want it to be installed, it says JMP Student Edition 19 cannot be installed on this disk. JMP is not supported on this operating system. Have you come across that before or no?
I haven't because I don't use a Mac, but is anyone else in here using a Mac have that problem?
Mine's not downloaded yet.
Okay.
I'll see when I get there.
Yeah. Yeah, there's quite there's like, well, almost everyone has half Macs here or so. But any issues with the Mac download so far? No?
No.
Yeah, it seems like that hasn't been an issue, but yeah, let me know if you are having any success, Adrian.
Yeah, it's not letting me do it at all.
Okay. Yeah,
I'm not like tech savvy, so if you want, I could email you a screenshot of this too, what it's showing me, just so you could see.
yeah, I probably can't, I mean, I can try to help you. You might have to contact the like support from JMP, but I can direct you in the right direction if you send me the problem. But yeah, if it doesn't get up and running today, no big problem. But you might have to make some calls. I'll see if I can put you in the right contacts.
Okay, sounds good.
But Adrian, you don't have it's not a work computer, right? It's not you don't have permission access issues?
No, it's my personal computer.
Okay. Yep.
is the laptop charger in here? My laptop has so fast.
I do. Is it the same? I mean, is it this time?
USB-C.
Oh, yeah, no.
No, no.
I just finished a class online. I have a PC on my. Or you have to do that with laptop and. Just higher than.
I mean, yeah, you're welcome to do whatever's most productive or efficient. You can stick around until it dies. You can head off to your other computer. Up to you.
I understand so that.
Okay. You have a charger, right?
I guess I'm at home.
Oh, okay. Okay. You can go grab it if you want. So it's, we'll probably get, so it's 9:17, just trying to give you all an estimate. Maybe we'll give it till, I'll start doing some examples and whatnot at 9:30. So just want to give everyone a few more minutes, or I guess 12 minutes to get this software going. If that works, great. If not, we can, I can help you another time, but I'll start doing some, I'll start the course material at 9:30. Yes.
Yeah, I got a couple of.
Got it good? Okay. Yeah, so again, it should look like this. Any luck with the software? Still going? We're good? Okay. Yeah. All right. Thanks. Is work?
Yeah.
Oh, great.
No.
Oh, excellent. All right. You'll have a second Saturday class today, or just this one? Just this one? Right, you get anywhere like 3 minutes. Everybody's back by then. Okay, but everyone here has the software? Yeah, okay. Anyway, Adrian, you're still having some issues. Anna, are you good with the software?
It won't let me download it. I still have the email that just says we're gonna review your account and we'll be in touch.
Okay, I had that same problem. It might take a day, but okay. I was just giving everyone till 9:30 to get the software going, so just got like 1 minute. Just, you have a plug over there? You have a plug?
Yeah,
Okay.
right.
Okay, so it's 9:30, so why don't we resume here? So I think a number of students have got the software working. If you're still having issues and they're looking into your credentials or whatnot, just no big deal right now. Just keep me updated, and we should be able to get it working for all of you this week at some point. But I'll start doing some JMP stuff. If you have JMP now and want to follow along, it's probably helpful. If not, again, this is being recorded, so you can catch up during the week once you get your software going. But if you know if the JMP student isn't working by like next Saturday, please let me know and we'll try to expedite it. But I'm hoping it's just a day or two, and it seems like most students here have already got it going. So you expect some tech issues in the first week. Okay, so on the D2L website, there's a week 1 section under either the course home or the contents here. I have some Excel spreadsheets we'll get to in a second, but I put a document up here called week 1 study guide and assignments. So see if I can make this a little bigger here. Okay, so what I have here is some key concepts that we'll go over. I have the first assignment, which we'll start working through today. And then, yeah, we'll see how far we get. But the first assignment, depending on all the access issues and the software getting up and running, we'll have it due next Saturday. But you know, if there's still issues getting the software working, let me know and I can always push it a week. But as of now, we'll leave it there. So on the web page under assignments, there should be the first assignment page. So I think you should be able to post your assignments here, but we'll get to that in a bit later. So why don't we? Where's my, there it is. Okay. So we just kind of took a break, so I'm not gonna start putting on videos real quick, but I do have a couple links to videos. I'll kind of disperse these throughout the class. We'll watch 1 or 2 of these, but if we don't watch all the videos, they're usually only like 5 minutes or so, but I'd encourage you to take a look. It kind of helps bolster the concepts. But some of the things we'll learn about today, we're going to start doing some simple regressions, some linear regressions in JMP and learning that. You might be familiar with regression analysis, but if not, we'll take a back step and do some background intro on that. We're going to learn about what the R-squared means, which is how you, one of the key things in which you evaluate the model for regression. You'll learn to interpret the coefficients when you're modeling like the effect of X on Y. You'll learn what that X effect is. P-value is going to be evaluating another way how the model is being validated. Are you confident in the results, or is there more that needs to be done? And then we'll spend more time on all these things, but residuals are the kind of error terms, and there's some desired properties that the residuals are supposed to follow to make it a valid model. So we'll go through, these are a lot of like intro key concepts to simple regression. You might be familiar with some of these from stats, or I don't know if you've taken like econometrics or something similar. But if not, no prior knowledge needed. But you will, I think you will like using JMP to do some of this analysis. So why don't we just the simple linear regression video? I'll leave that for you all to watch. It's just showing. Let me just pull it up for the diagram piece of it. Yes. So, oh, that was so loud.
Well, I thought it was just in the list. It's not like hardly interesting.
Oh, you can try moving up here or a different, yeah. Okay. Well, let me just get to the, all right, so we don't need to watch the whole video. I just want to give you like a key rundown. So there's going to be an x-axis and a y-axis. And essentially, let me take out that page caption. Essentially, you're looking at trying to measure the effect of the x variable on the y variable. So when x changes, what happens to y? And then, you get this is just a simple case, but this is like, when x is this, y is this is one observation. This is another observation. There's like 1, 2, 3, 4, 5, something like 10. And we're trying to estimate a linear line that best estimates the relationship between x and y. So essentially when x changes up or down, what happens to y? And in some cases, there might be no effect, but this is the simple case is we're gonna look at a bunch of data points. We're gonna try to measure in all these different ways, how when you change x, what happens to y? And then, the closer the points are to the line, the better the linear fit. And in some cases, if it's more of like a horizontal line, that's gonna be, there's no fit or no effect. So, it's a pretty simple concept. Well, you can take it pretty far, and it's a good way to start, is just looking at, we're gonna look at some data sets. We're gonna look at how, you plot the points, and we're gonna look at just estimating the kind of correlation between x and y, and then measuring the effect of x on y. So this is like a 5-minute video. You're welcome to take a look. It can't hurt, but I'll kind of dose in some videos as I think are fit, but this one I think is best for late. What am I? Okay, so maybe I'll open this again. Okay, so these other concepts, we probably will take a quick look at the videos when we get to that concept. So R-square, p-value and residuals, and then just interpretation of the model are all ways we're gonna evaluate simple regression. Let's take a look and do a quick example together. And the way I like to kind of structure the class is, I'll have a larger assignment that we'll do, depending on time. We'll do a good portion of it together in class. And then once I think you have the skills to finish it, I'll let you go on and finish it. But, one of the benefits to come into class is you'll get some of the homework and some of the work done. So I'd encourage you for that reason just to come to class, or even if you're on doing it via Zoom, you can do it simultaneously. I know that Adrian and Anna both have tech issues, but once things are up and running, you can probably do it as we're doing the course. So why don't we just look at the first example, and it'll take a minute to figure out like what you're turning in and how to work with JNP, but the way it's probably going to work is there'll be a number of questions. You're going to submit to the assignment section or the homework section. What's it called? Assignments. Assignments. You're going to submit a specific JMP document or file for each question, and then there'll be one like Word or PDF with some summaries of answers. Okay, so why don't we look at, and again, this is due next Saturday, but that's pending on everyone getting this software done. All right, so very first thing is, the back step from regression is correlation. And this is from the JMP Learning Library. Right? A lot of this stuff was, last time I taught it, it was on Blackboard. I had this whole archiving and like recreate it, so I did, some of the things got lost in the black hole somewhere, so I did have like the very first, homework assignment or question, I couldn't find it, so anyways, I had to kind of modify a bit for the first one, but it seems like 95% of the stuff is findable, but my like very first example I always use for this class is gone. But anyways, I can pivot. So if you go on down to this JMP assignment 1, and you click on this link. Okay, so this is going to show you a simple method of and this is from the JMP Learning Library. The thing I like about this is they have a quick 1-minute video to do the concept, and they also have this PDF guide here. So either one can be used to do the analysis, but it's a very, each concept has like 1-minute video, 1 page to do it. So it's pretty efficient. So why don't we, let's start doing this.
This jump demonstration shows how to visualize and quantify correlations among continuous variables. We are using the body measurements data from the sample data library.
Okay, so we'll try to do this together just so we get the hang of it. So if you have JMP student, let's go ahead and open it up. And it's going to look, so there's a little quick start tip of the day. You can close that or whatever you want to do. So the first thing we're going to learn how to do is there's a whole sample of data sets we can use for analysis. And the first one, this body class, this body measurements one, we can just find it in the sample. So
you can get all the data sets we're gonna use on the
either they'll be on the JMP database or I'll post them on I'll post them for you. Some of them I have just from other courses, but this one, so here's JMP. So this was what it should look like when it's open. I don't know if the Mac version is slightly different. If it is, I can work around, but I think if you have this open and click on the help menu, and if you go down to sample data folder and click on that. Okay, and that should take you to this, directory. It's already been like you can also find it on your in the your C drive or whatever, but this is a shortcut. So it should just take you there. And if you scroll down, you can find the one they're talking about. Body measurements, right? You see that? And so if you find the body measurements one, you can just double click it. And it should open up right in JMP. Like, all right, and so there you go. You have a data set of different body measurements: mass, forearms, biceps, chest, neck, shoulder, waist, height, calf, thigh, head. So, was everyone able to get that? Yeah. Okay. Excellent. And again, if the software isn't working, this is being recorded, so you should be able to replicate it at a later time. All right. So, navigating this. Okay. So we open that and
We'll start by assessing a single correlation between forearm and bicep measurements. Let's begin by going to Analyze, fit Y by X. We'll place one variable into the Y response role and the other into the X factor role. When we click OK,
so we'll do that. So you have this, and then the simplest way to do a correlation and eventually regression is there's an analyze button. There's a fit X by Y, which is what we're doing. And then we're going to pick the two variables that you could pick any of them, but since we're doing a simple regression, we just need one X variable and one Y variable. So we're gonna put the forearm variable in Y and the bicep variable in X.
So would this, correlation be analyzing the effective X factor on Y response?
Yes, that's correct. Yeah, exactly. 100%. Okay, so forearm goes, what was the X one?
Bicep.
Okay, yeah, so that's exactly right. We're looking at, how when biceps change, what's the effect on forearms? It's kind of a, not our typical, statistical model, but we get the idea. All right, and then it'll, down here, it chooses which, it knows we're just doing a simple, linear fit, the bivariate. Once we start doing more advanced things like logistics and predicting probability, we'll look at nonlinear distributions, but in this case, just put forearms in the Y, biceps in the X and hit OK. And then you should get this, little scatter plot. So this shows you different bicep and forearm observations. And we haven't done anything yet except plot the graph, but you can see that the first thing you see is there's a relationship, right? So just in general, when the bicep variable goes up, what happens to the forearm variable? It goes up, right? Yeah, you can see there's a positive relationship. It doesn't look perfect, but it looks pretty clear that the bigger the biceps, the bigger the predictability of the forceps. All right, and then we can do the rest of this.
We're presented with a scatter plot of the data, which here already seems to show a relatively strong positive correlation. We'll calculate Pearson's correlation coefficient by going to the red triangle and selecting summary statistics. We can see that the correlation is approximately 0.81, with a confidence interval from approximately 0.6 to approximately 0.92. To help visualize this correlation, we'll go to the red triangle and select the 95% density ellipse. This is an example of assessing a single correlation, but sometimes we want to assess many pairwise correlations at once.
Well, if we get what we're doing, let's do those two things. So it should, there's all these, JMP has all these different windows. So anytime you do something new, it goes to a new window. So just note that like you're gonna have all these windows open, but this is the data set. This is the, oops, that's not the data set. This is the data set. This is the analysis. And it should be a little bit easier to navigate. If you're not sharing on Zoom, it's kind of hard to go back and forth, but we'll get the idea. But I need to go away. There we go. Okay, so red triangle up here has a bunch of options. The first one was summary stats, all right? And so you can see the correlation right here. So the correlation between forearms and biceps is listed here. So this is on kind of like a 0 to 1% split. So basically, there's like an 81% correlation. If this was 1, it's like a perfect line. If it was 0, there's no fit. So it's on a scale of 0 to 1. It's pretty good fit. I mean, it's pretty clear that when biceps go up, forceps also go up. And if you do the let's see, this one, right? And 90%? 95. Okay. So what that's going to show you is that this is like anything outside of this eclipse, if you will, there's only a 5% chance of that. So you're pretty confident that your observations and correlation is going to be within this ellipse. This one does appear to be an outlier, so this you wouldn't expect. It seems like with that level of bicep that the forearms are pretty high, so that is kind of outside the prediction. But the idea of this is like anything in this, which is a pretty big window, so it's not not predicting a great lot, but anything in here is you're 95% confident that if you have a bicep measurement in here, that this is the forearms. Anything up here or down here is more of outside the measurement, and so that's what we call an outlier, because we wouldn't expect it to be outside of this ellipsis, but doesn't mean it's not possible. Okay. So,
Once. Let's assess all possible pairwise correlations between the variables in our dataset. To do this, we'll go to Analyze, Multivariate Methods, and choose Multivariate. We'll place all of our columns into the Y columns row and click OK.
Well, back to this. All right, so back up here, or sorry, drop down menu, Analyze, Multivariate Methods, and then Multivariate. Okay, and what they did is we're gonna look at the box plots of everything. So you can select multiple things at once if you just you can use the mouse or just do shift down. And then you should be able to drag everything at once over here like that. And that should put every variable from mass to head in this Y columns. Then you hit OK. Okay, so this is this shows you a scatter plot matrix, which is a bit, not the most visual thing to look at, but it shows you kind of the correlations between different variables. So you'll see things that have like, so like the ones that have, when you're looking at like mass on itself, with mass and mass, there it is. So this is like or if you look up here, so the scale is like 0 to 1. So the reason mass is a perfect correlation of mass is because it's the same variable, and the same for like forearm and forearm. So all of the variables on themselves should be a perfect correlation. The other ones we don't know yet. So if you look at like mass and forearm, it's a pretty good positive correlation, right? If you look at something like chest and height, not much of a right. I don't know what's going on. So if you see just all these ones down here, they're just kind of like there's no clear correlation, and there probably isn't one. But the ones like see shoulder and waist, right? You can see a correlation. So it's likely if you did a fit of the line or did the correlation that you'd see one. So it's a nice visual just to look through and see like, okay, these two are correlated. This is correlated, but things like this, mass and height, forearms, looks like height's not really correlated much, but so you get the idea that the less clear the relationship, you should get a lower correlation. So like this one, forearm and height should be pretty low. Forearm, yeah, 0.35, that's not very high. So anything under, 60% or something like that is not very high, but and the same with like, look at this one, waist and head probably should be a low correlation. Waist, head. Yeah, not a high correlation. But if you look at like the ones that are, here's 82%, or this one's 85%, shoulder and mass. That should look visually like a relationship. Shoulder and yeah, there we go. So you get the idea. If you're developing a model and you're looking at what you want to like put into your model and what are the correlations, this is a nice way to say like this is no relationship. Don't worry about it. But yeah, I think it's pretty helpful. So correlations are simple, but they also give you a good starting point of where you go. Anything else in this tutorial? Let's see.
We're presented with a correlation matrix showing the Pearson correlation coefficient for every pair of variables. Note that the diagonal reads 1 for all correlations because each variable is perfectly correlated with itself. Below that, we have a scatter plot matrix to assess each correlation visually. The red triangle next to the scatter plot matrix contains many helpful options. For example, we can again add density ellipses to help us visualize the correlations. Under the top red triangle, we can find options for many further multivariate analyses and data visualizations.
Okay, the last thing was that it didn't really tell us much, but if you want to do the scatter plot matrix density ellipsis, you can see, and the ones that have no correlation, you can't even see the ellipsis, right? This one, we're 95% confident it's going to be inward, so that doesn't tell you much. But the ones that are thinner, the ones that are more like a cigar, it's a more clear, like these two here, that's a pretty clear upward relationship. But some of these, like this one, and ones that are just the whole area are not much of correlation. Yes.
I don't know which like where to use this. They don't have to like mass and form, the one on the top left, there's like one right underneath mass.
Oh, good. Okay, good. Yeah, good question. So you're looking at, so this is, there's only two combinations, right? So if you go like, so this is showing the relationship between mass and form, right? So you're looking for a y-axis and you're looking for an x-axis, right? So if you go here, you're looking at the correlation between, I guess they're the, these two are the same. This is form on mass and this is mass and form, but there should only be one combination, right? So even if you go all the way here, what are we looking at? Mass and head, right? So just go all the way to the end until you see something. And the same with this one. And then like this is form on head. So it's kind of hard to, visually see it, but it should be pretty clear. Like if you pick this one, it's chest on cap, right? Make sense? And then you can go like, there's two combinations of the same because you can do shoulder and waist here or shoulder and waist here, but it should be the same thing except the variables are flipped. What?
It's like shoulder, waist, and waist to shoulder.
Yeah, exactly. Yeah. So in this case, shoulders on the y-axis and x is on the x, and it's flip-flopped here. So if it's on, this part, then it's the y-axis or this part. If it's on the top or bottom, then it's going to be the x-axis. Yeah, it takes a bit of looking around, but okay. Any more questions on this exercise? They're pretty basic, but it's a nice starting point, I think. And kind of the first thing we'll look at is correlations. So that's the first exercise, and trying to keep things simple to get us going with JMP. Well, the first question, but so if you've got to this point, let me just show you how to save the document. So there's two things you save. So you save all the analysis you've done, and then you save the whole document. So the first thing you want to do is, so there's, let me see how many windows we have. So there's this one, and there's, yeah, so if you look at your JNP, and sometimes it's hard to keep track of because there's multiple things we did. So you don't have to worry about the home window, and you don't have to save the like data set, but all the other analysis it's nice to save. So this one, you click on the one where we did like fit X by Y. The way to save it is go to the very top and like the red triangle here. And if you click on this and save script to data table, then it's going to save it to the primary data set. And you can leave a name default or change it whatever you want, but I usually just leave it. Okay, and then if you save that, and if you close it, you should be able to access it from the body measurements data set right here. See, it should show that little fit X by Y. If you click on that triangle, it should be saved, right? No, of course. So if you have this one, the bivariate fit X by Y, click on right here where it says like bivariate fit, click on the red triangle. And then go down to save script. And then go to data table. And then just hit OK, or you can change the name if you, that's it. Okay, so we saved that one, and then there's one more we did, right? This guy. Where's that one we did? Yeah, we already saved that.
Yeah.
Right, so then the correlation matrix, we can also save this and just go to the very first red triangle part, save script to data table. Multivariate's fine. And if you close that, see now we have, I like to get it down so we just have the home tab and the data set with all of our analysis we can open and close. So there's the fit and there's the correlation. Yeah. Okay. So then you can save this whole data set to like upload for your homework. So then, and this might be a little bit different for Mac, but I think it's pretty similar. File, save as, and it's going to be a .jmp document that you submit for your homework that has those data tables in it. And I think it's just easier if you, so I don't just leave the same name because if everyone says body measurement, it's hard for me to keep track of who's who. So the easiest thing to do is either just put I like to just put your initials or your name at the end. So you can do body measurements, and then I'm going to put JJH for myself. Or you can put your full name, whatever you want to do, just as long as I can identify it, and then try to be consistent so I can see like, oh, this is, and then if you save it, would you like to see? What? No information is going to use. Oh, okay. Yeah, sorry, yeah, I'm defaulting it onto you're right, the C drive. So let's save it. If you have like a folder location for this class, you can save it there. So just save it to your normal OneDrive or whatever you do. And it should save. And then if you close it, so if I close the whole thing, just want to show you how to, and then you go to where it was saved. Okay. This is what I think, yeah, so if you save it somewhere, you can just open it up, double click it. And it should take you back to what you already did. From that. Hopefully.
Now this is the file you want to go.
This is for the first question, yes. Correct. Okay, and then see, all your stuff is there, right? And this was a pretty simple one, but you know, sometimes we'll have like 10 different analyses and you can access them and look at the table, and then you know it's got everything saved for you. Okay, so any issues with the saving or the documentation? Good. Okay. All right, so why don't we just close this again? Just open up everything. It asks you a lot. It really doesn't want you to lose it. It just keeps asking. What, new one here? I don't know that. New one, open. Okay, so then I want to show you, or I want to confirm that we can submit these on the course webpage. So I'll take myself off this. I'm gonna go to my default instructor account. So if we go to assignments, and I just made one for JMP1, click on this. I don't know if I can submit something myself. No. Oh, I'm showing all of yours. So I guess, are you able to? Is the way that assignments work, can you submit one thing and then submit another thing later, or do you have to submit all?
Upload multiple.
Okay, okay. So you can go ahead and upload that and just see if it works. And then I'll take a look and see if I can see some of them. So just try to submit that JMP document to your name. It worked? All right. Let's see. Oh yeah, I already got 3 of you. Okay. Cool. Okay. Excellent. Okay, and then you can attach a second document with it. Okay, perfect.
As long as it's open as an assignment, we can attach it if we want.
Excellent. Okay, and then you can't see each other's, right? Okay. I mean, I don't. Yeah, no, I can see them, obviously, but, yeah, all right, gotcha. Cool. All right, so that's how we'll submit assignments. Pretty self-explanatory, but sometimes there's some logistic issues, but yeah, excellent. All right, so you've already done like part of your assignment. Okay, why don't we move on to another example? Let's see. Oh, that's my. All right, back to week 1. Okay, so the first assignment, you've already saved your scripts in your JMP file for question number 1. So you've done a lot of you already. Question number 1, just to get us started. All right, and we'll do another kind of simple one, and then questions 3 and 4 will have some more interpretation and some writing. All right, ready for another example? Okay, so now let's take the correlation to the next step. And so we know that we can see a visual plot of 2 things and if there's a relationship. But now let's learn how to estimate the best fitted linear line through those. So if we click on this simple linear regression link, it should take us to another one of those examples. And again, there's a quick video or there's a little PDF guide that also is helpful. So this one.
In this video, we're going to see how to perform simple linear regression, an analysis when we want to model the relationship between 2 continuous variables. I'm using the big class dataset available in the sample data directory. To perform the simple linear
Let's do that first, just get that. And all right, so to get the sample data set, let's do help. Sample data folder. That should take you back to this, and then we want the big class. This one here. Just double click it to open it. And that should be it. And I'm gonna close this so I don't have to. Okay. So what do we got? All right, so we've got a bunch of, arbitrary names and different variables, so we can tell if they're male, female, their height, and their weight. So I think we're going to try to estimate the relationship between height and weight, or vice versa for this fit class data set.
Regression in JUMP, we can use one of two platforms, either analyze fit y by x or analyze fit model. For this example, I'm going to use fit y by x. Fit y by x is a contextual platform, like all platforms in JUMP, and so it'll produce different output depending on the modeling types of the variables you provide. In this case, I want to predict the weight of students on the basis of the height of those students. I'll cast these variables into their associated.
All right. Back to here. So analyze fit y by x. All right, and then we can put the weight as the y and the height as the x. That's what I did, right? All right, and so we're going to estimate the effect of height on weight if height goes up or down. What happens to weight, and then let's hit OK. And there we go. We have a nice little positive relationship. It's not perfect. You can see like the low observations aren't part of the perfect correlation, but it's pretty clear that, on average, when height goes up, weight goes up, which should make sense if you, as a general theory. All right.
It rolls, and you'll notice JUMP will designate this analysis as a bivariate. When I click OK, JUMP will produce the scatter plot of height on the x and weight on the y. To run the linear regression, we'll go to the red triangle and select Fit Line, which will produce the linear fit information, summary of fit data, analysis of variance table, and parameter estimates for regressing weight onto height. In this case, we can see that we have a statistically significant effect of height on the weight of each student. Under the parameter estimate section, we can also see the actual beta estimate, standard error, t-ratio, and p-value for this relation. Under the red triangle next to linear fit, we have several other options that might be of interest, including saving the predicteds or saving the residuals to the data table, plotting the residuals, adding confidence intervals, including shading and confidence intervals for the individual fits. I'm going to run save residuals, and you'll see that the residuals for this analysis.
Let's do that first. So back to this data set. So if we click on the red triangle here, and we click on fit line, that's going to fit the regression line. So this is, we're minimizing the distances, we're minimizing the sum of the squares. So this linear line is supposed to be the least distance from all of these data points on average. So there shouldn't, in theory, be a better linear line that fits these. Like if it goes more this way or this way, it could be better. And it's not, a perfect correlation, but you can see that on average, when height goes up, weight goes up. Okay, so we're gonna learn some of these key terms here, like R squared and p-value. I guess one of the first things is just to understand what this equation is. So here, if you can see this equation here. So this is showing the simple linear estimated regression equation of height on weight, right? So you can see that there's a negative because the intercept starts below the x-axis, and then this variable or this coefficient, which should be similar or exactly the same as this one here, is the effect of height on weight. So height is changing. Oops. Okay, so I'm assuming that this is weight in pounds and height This is like. Assuming that's like 5'9", I don't know, actually, these are, so I'm not sure, this is, height might be in some other. Metric, but it doesn't look like it's. They're obviously not, 62 feet high, but, I'm pretty sure this is in pounds and this is something else. I don't have the,
So the line equation was just basic y was in,
yes.
and then the b is an exact, obviously, when the slope is the expected height on weight.
That's right, yeah, that's exactly it, yeah. So, trying to figure out what the, oops. It'd be nice to know what the metrics are, but it's okay, we can do this as an interpretation, so. What do we think this, so this, I think this is weight in. This is weight in pounds. Is this height in like inches? Okay, excellent, yeah. Okay, excellent, all right, so this is, so each time we move across here, it'll go down, that's 1 inch. And each time we go up or down, that's 1 pound, right? Okay, so then the important thing is knowing that when this height variable changes, it's changing by 1 inch, right? So in particular, we're interested not so much as the intercept, but this coefficient attached to height on weight, which is like you just said, the effect of height on weight. So this 3.7 to round up or round off. How do you interpret that 3.7? Exactly, like what does it mean quantitatively? More or less, yeah. So it means that when height, on average, this is all average, like this is obviously not perfect. When height goes up by 1 inch, when one observation goes up by 1 inch, we'd expect weight to go up by 3.7 pounds, right? Each time, right? Or so that, and then same goes the other way. Like if height goes down by 1 inch, we expect weight to decrease by roughly 3.7 pounds. So the estimate here, the parameter estimate, or the coefficient, I like to call it, that's attached to height, is kind of the most important thing in these simple regressions because it shows you exactly what you're measuring, right? So we expect that every time height goes up 1 inch, that weight would also go up by 3.7 pounds on average, right? And that's really the most important thing is understanding. So you see how we had to, like, it's the effect of X on Y, or when one goes up, one goes up, but you have to know the metrics to know the exact interpretation. So since I didn't know exactly what the height was, I couldn't tell you the estimate. That's all I knew was inches. So you have to know what the X variable is. You have to know what the Y variable is, like what it's measuring, and then you can interpret what that estimate means, right?
Because we're bringing the big one, it'd be like for every 1 foot.
Yeah, it would change. So if it wasn't feet, it might have changed the the slope of the line because this is a different. So if this was feet, what's 60 inches compared to a foot? 5. Yeah. So this is like 5. So that's going to be a lot different. That means like when it would be the same, the same thing, just a different scale, right? Yeah. Okay. And then, so what do I want? So I want to show you a few more things. So the first thing is the linear fit, and then the parameter estimates. Questions on that? And good so far. And then a couple more ways to analyze the model or look at the effort or the p-value here. And then also the R squared or the adjusted R squared. They're kind of small, but you can see them better on the screen. Not that you want to be glasses to see them like I do, but the good news is the highlighting tells you like the JMP does this like color coded system, and you'll know if the p-value is small enough or big enough to be, like, to quantify the significance. But I have a couple quick video concepts on these two things, and then we can interpret them in the next version of the homework. And then look at the residuals. So why don't I show you, before we discuss it more, let's talk about the R squared, which is a way of evaluating how well the model values the changes in the y bit. So I think I have it. Okay, so what is R squared? Let's see if that works. Oops.
Enhance your membership with the American Express Platinum Card. Access over $3,500 in annual value.
Hello and welcome back. Today we're talking about the R squared, a very important concept when it comes to evaluating the goodness of fit of our models. Now, in order to understand R squared, we're going to need to look at two versions of our chart. So here is our data set, and what we're going to do here is plot the regression as we were doing before. And here's our data set again, and this time we're going to just plot an average line, and we'll see that in a second. So we'll start with the regression. Let's draw our regression line. As usual, let's project vertically our data points onto it. And for each data point, we're going to look at the difference between yi, the actual value, and yi hat, the predicted value. Now, as we discussed before, the way we build this line is we're minimizing this sum over here, and that is the ordinary least squares method. Well, actually, this sum has a name. It's called the residual sum of squares, and it's indicated by this abbreviation. Now, on the right here, we're going to draw an average line, and this is simply taking all of the y values, so the actual values of our data set, the y values, and taking their average. Again, we're going to project vertically our data points onto this line, and for each data point, we're going to look at yi. And here we're going to calculate another total. This one is called the total sum of squares and is indicated by this abbreviation. And it's similar to the residual sum of squares, but instead of using yi hat, we're looking at the difference between yi, the actual value, and y average, the average value of our data set. And now we can calculate R squared. R squared is defined as 1 minus the ratio between the residual sum of squares and the total sum of squares. Now let's pause here for a second and discuss this a bit. So we know that we're minimizing the residual sum of squares. We want to make it as small as possible. And from these two images, you can already see just by judging based on the lengths of these blue dashed lines, we can see that they're generally longer on the right where the average is, and they're shorter where the regression is. And that's because we've designed our line to minimize these lengths so the sum of squared is smaller. And so what that means is that the residual sum of squares is usually, in most cases, it's less than the total sum of squares. So the way to think about it is in the total sum of squares on the right, you're just putting an average line. You're not modeling anything. This is the most rudimentary thing that we can do, is just put an average line and approximate our data with that average line. Of course, it will be, and it should be, worse than any thought out model that we create, which is the example on the left. So thereby, unless our regression model is facing absolutely the wrong way, for example, a downward slope on the left over here, if our model was sloping downwards, then the residual sum of squares would be huge because our model is just incorrect. But in all other cases, the residual sum of squares is less than the total sum of squares. And what that means is that the ratio is less than 1. So R squared is somewhere between 0 and 1. And the better our model fits the data, the smaller the residual sum of squares will be. And that means the greater R squared will be. So here's a quick rule of thumb for R squared. Now, bear in mind that it highly depends on the context. And this rule of thumb is just for the practical tutorials that we're looking at in this section of the course. And here we go. So if you have
a 1, R squared of 1, that's a perfect fit. That means the residual sum of squares is 0, and basically your line is going through all the data points, which is virtually impossible, so it's very suspicious. If your R squared is about 0.9, that's a very good model. If your R squared is less than 0.7, it's not a great model. It's not the end of the world, but not great. If it's less than 0.4, it's quite a terrible model. And if it's less than 0, then the model makes no sense for this data, as we discussed. So there we go. That's how the R squared works. A very important concept to understand because it's used quite a lot to evaluate models. I look forward to seeing you next time. And until then, enjoy machine learning.
Okay, so that was a nice overview of what we need to talk about. So the concept of getting it closer to the two lines is mathematically what we're looking at. You're not going to have to recreate or measure the model. You might have done so if you did stats. If you're so mostly understanding the value and what it means intuitively is the point here. But if you're interested in recreating or calculating the R squared value by hand or with Excel or something like that, I can show you. I've done it before, but mostly just understanding what it means is what's important. So the end of the video showed you that it's essentially there's a scale, and you're looking at, and note that the R squared is only in applicable or what applies to the Y variable, in this case weight. You're looking at how much is explained. So there's usually an R squared and an adjusted R squared. It's kind of a best practice to use the adjusted because if it's one variable like this, they're pretty much the same. But the R squared or the adjusted R squared, if you have a multiple regression that adds another variable like x2 and x3, like other things that predict weight, then the adjusted R squared will adjust if you put a variable that shouldn't be in the model. Like if you put like the price of oranges in this model or something, that shouldn't add any predictive power. So the adjusted R squared will quote unquote like punish you for putting in bad variables. So it's a best practice just to use the adjusted because it adjusts for statistical mistakes. But in this case they're pretty simple. It's 0.5 or 0.48 or 0.49. So this R squared is the percent of explained variation in the Y variable. And like the video noted, like if it's 1, it's a perfect fit. And if it's 0, it's no fit. But this is how much, like when, in this case, we only have the one variable, but when height moves around, how much of that can be used to predict weight? And in this case, since this is on a scale of 0 to 1, anyone want to take a shot at interpreting the 0.5 or 0.49 as what it means in this model? Yeah, but what's the percent accuracy? Yeah, pretty much. So it says that, or it translates to this model here. In this case, it just explains about 48% or 50%, what have you, of the weight variable. So essentially, and this is just on average, but you can predict about half of this variable's variance by just using height, right? If you add more variables, you can probably get it closer to 0.9 or depending on the model. But this shows you how much of this Y variable you've explained in this particular iteration of the model. So in this case, not great. It's about 50%, but I wouldn't go so far as to say it's like a terrible model like the video showed, but it's just, the better the explaining power, the closer it is to 1. So if you're getting something like, and sometimes it depends on what you're looking for. A lot of times you're looking at interpreting the variables rather than explaining the Y variable. So it's important to know what this means, but just knowing that this is high or low doesn't really qualify or disqualify the model. It depends on what you're actually trying to estimate. If we're looking particularly at what explains weight, we can probably get a better model. But if we're looking at, just the linear correlation between height and weight, this is probably a pretty good estimate. So it's taken with a little bit of a caveat that if we want to explain weight, we should probably get a better model. But if we just want to look at this simple relationship, it's probably fine. Okay, so just interpretation would be something like 49% of the variation in weight is explained by this model, something like that. And then we had one more concept I wanted to show you, which is the p-value, and this is showing essentially the probability that this relationship is accurate with like a 95% level of confidence. So I have one more concept video on p-value, and then we can interpret it, and then we can do some more. So, let's see. Let's see how we can get percentage. All right, so we've done a regression, we've learned about R squared, we've interpreted the coefficients. The last two pieces for today are p-value and residuals. We got some more practice, but let's learn this last concept, and then we can interpret it in the GMP.
Understanding the p-value. One of the most important concepts in statistics.
If you're not doing this before your release ends,
Understanding the p-value. One of the most important concepts in statistics is the meaning of the p-value. Whenever we use Excel or other computer packages to analyze data, one of the key outputs is the p-value, or sig. In formal terms, the p-value is the probability that, if the null hypothesis were true, sampling variation would produce an estimate that is further away from the hypothesized value than our data estimate. In less formal terms, the p-value tells us how likely it is to get a result like this if the null hypothesis is true. We will now go through this step by step with an example. Helen sells chocolati's. Recently, she has received complaints that the chocolati's have fewer peanuts in them than they are supposed to. The packet says that each 200-gram packet of chocolati's contains 70 grams of peanuts or more. Helen can't open up all the packets to check, and then she wouldn't be able to sell any. So she decides to use a statistical test on a sample of the packets. The null hypothesis, often called H0, is the thing we are trying to provide evidence against. For Helen, the null hypothesis is that the chocolati's are as they should be. The mean or average weight of peanuts in the packet is 70 grams. The alternative hypothesis, called H1 or HA, is what we're trying to prove. The customers have complained that the weight of peanuts is less than what it should be. So the alternative hypothesis is that the average weight of peanuts is less than 70 grams. Helen decides to use a significance level of 0.05. If the p-value is lower than this, she will reject the null hypothesis. Having decided on her hypotheses and on the significance level, Helen takes a random sample of 20 packets of chocolati's from her current stock of 400 packets. She melts down the chocolati's and weighs the peanuts from each packet. If all of the values were lower than 70 grams, with a mean of 30 grams, for instance, it would be quite obvious that the bars did not have the required number of peanuts. It is very unlikely that you will get 20 packets with a mean of 30 grams if the overall mean of all the packets in the population is 70 grams. Conversely, if all the values of the 20 packets are much higher than 70 grams, it would be obvious that there were enough peanuts and that there was nothing to complain about. However, in this case, the 20 packets contain the following weights of peanuts, and the mean is 68.7 grams. This caused Helen to ask herself, does this provide enough evidence that the bars are short of peanuts, or could this result just be from luck? She asked her brother to use Excel to find the p-value for this data, comparing with a mean of 70 grams. The p-value is 0.18. Judging from the data that we have, there is an 18% chance of getting a mean as low as this or lower if there is nothing wrong with the bars. That is, if the null hypothesis is true and the mean weight of nuts is 70 grams or more. This p-value of 0.18 does not provide enough evidence to reject the null hypothesis. In this case, Helen does not have evidence to say that the bars are short of peanuts. This is a relief. The smaller the p-value is, the less likely it is that the result we got was simply a result of luck. If the p-value had turned out to be very small, we then would say that the result was significantly different from 70 grams. In general, we start by saying that the null hypothesis is true. We take a sample and get a statistic. We work out how likely it is to get a statistic like this if the null hypothesis is true. This is the p-value. If the p-value is really, really small, then our original idea must have been wrong, so we reject the null hypothesis. P is low, null must go. A small p-value indicates a significant result. The smaller the p-value is, the more evidence we have that the null hypothesis is probably wrong. If the p-value is large, then our original idea is probably correct. We do not reject the null hypothesis. This is called a non-significant result. The p-value tells us whether we have evidence from the sample that there is an effect in the population. A p-value less than 0.05 means that we have evidence of an effect. A p-value of more than 0.05 means that there is no evidence of an effect. Sometimes a significance level different from 0.05 is used, but 0.05 is the most common one. Disclaimer. This video uses plain language to get difficult ideas across. Some terminology might be viewed as incorrect by a rigorous statistician.
Okay. I think all right. Okay, so the p-value on that example. It's right here. Okay. So as was illustrated, this goes back to the old hypothesis test, but this is telling you the probability that this model is accurate. And so what this is essentially, if the p-value is less than 0.05, that means you can say with 95% confidence that this holds on average for essentially if you did this experiment again with nothing changes with the same students or similar students, this would hold, and it's only an average effect. So saying that the average effect of height on weight isn't a huge leap, but if the p-value is like 0.2 or something over 0.05, then you're losing confidence in the model, and it's probably more of a scatter thing. So JMP will tell you, like, see, it's red. It's telling you that it's low enough, and there's a little star. Actually, let's see. I'm trying to use it. Break out. But it'll indicate, with a star with some coloring, if it's low enough. In this case, it is. But if you see a p-value in some other models or relationships that's like, 0.2 or 0.1 or something that's higher than it should be, then it's going to disqualify the relationship. But in this case, it's a pretty low value. It's telling you that this average effect holds, and you can be, statistically 95% certain that this average effect is true. All right, and that's really all it tells you. But it's an important thing to check because, one of the first things you want to look at for any regression or model is the p-value. And if the p-value isn't in the right threshold, then the whole model is irrelevant, right? So if the p-value is 0.5, then this doesn't matter. It's not going to statistically be meaningful. So it's something that's good just to have a look at. JMP will kind of tell you if it's in the right threshold, but just knowing what that means is important because this really just gives a thumbs up or thumbs down to the whole model. Okay, so,
I have a question, Professor.
yeah, please.
So just in this scenario, let's just say the p-value was high. I'm not understanding how that affects this current data. Well, I
Yeah,
understand it wouldn't be good, but in terms of like how or like why, I guess.
yeah, that's a good question. Well, so in this case, because there's only one X variable and Y variable, it's pretty clear how you can mess it up. So let's say that we looked at one of those other, like, let me see if I can find those for this example. To show. Actually, let me, before I do that, I'm going to save this just so I don't lose this anyway. So at this point, why don't we just go ahead and let's see. Actually, I can get back to it. Body measurements is the first one, right? Okay, so for this one, if I look at these, all right, so if I were to do a similar analysis with like biceps on height, or one of these other ones that have a very low correlation, it's probably going to give me a very poor p-value. Or it might just give, or it's going to give me like a very high limited confidence. So let me see if I can test this theory.
So it's pretty much just confirming that there's no correlation.
Well, for two variables it is, but if we get models that have like another X variable or two or three or four, and you're looking at multiple things and it can explain the Y variable, then it's an overall analysis of like all these things together. But in this case, yeah, the way you interpret it is right. But if I was looking at like the effect of forearms, biceps, chest, and neck on mass, the p-value would look at the overall, evaluation of the whole model of how these four things affect mass. But in this case, yeah, it's a simple, if there's not a good correlation, it's not going to be very high, right? Let's look at, or I mean, if there's no fit, then the p-value doesn't tell you much, right? So let me see if I can, because it's only one variable, it's what was it? Okay, so what are the ones that have no? Let's try chest and height. That's a pretty good poor correlation, right? Chest and height. Okay. Chest and height, it's a theory. All right. So here's our not so clear relationship at all, right? So we're to fit the line. Fit line. All right. So look at the p-value here. So this is saying that here's a line, but if you take away all this stuff down here, it's not clear to me that this line represents anything, right? It looks like height can be anywhere and chest can be anywhere, right? This is the best line, but it doesn't really. I wouldn't present this line and say like this is the effect of height on chest, right? And if you look at the p-value, it's 0.3, so it's like a train wreck, right? So that's because it's a simple example, you can just do the way you interpreted it, Adrian, but if there's more variables which we're going to look at, then it's a little more complicated, but yeah, this is a good way that was a good question to look at the alternate, yeah.
Okay, yeah, I'm understanding. Thank you.
Yep.
Yeah. It's better if it's under 0.05, because that means there's a 95% confidence there.
Yeah, that's right.
So if the P value of 0.35 here, that gives a 65% confidence that it has an effect test because not really confident.
Correct. Yeah. That's right. Yep. Yeah, so so we're looking for, and you can tell that JMP didn't highlight it this time, but it's not red or whatever color it was, and there's no star. So it's telling you like this is not a good model, and you don't even need the analysis to tell you that. Like, it's what you put this away. Oops. And just look at the linear fit, and like even if I took away if I just looked at the scatter plot, there's no way I can tell an effect of chest height on chest, but I can look at the stats to confirm, it's not a good example. Right. Okay. All right. Good questions. Let's get this. What's this? Maybe. Isn't this up high? No, it is. Okay. What we do? We're going to finish the exercise, right? Let's see. Okay, so we did everything up to here, I think.
Analysis are saved to the data table. In diagnosing linear regression, it's often important to look at these
Oh, yeah, we have to do residuals, right? Okay. I think that's the last thing.
residuals. And Shelf makes this very easy by plotting the residuals directly in the analysis. Selecting plot residuals produces several diagnostic plots, including residuals by predicted, the actual scores by predicted, residuals by row for diagnosing non-independence, and residuals plotted against X. If we're diagnosing the normality of our residuals, we also get the residual normal quantile plot, showing the expected eccentricity of the residuals, assuming that they form a normal distribution in the population. Residuals falling along the diagonal then indicate that those residuals are where they're expected to be if they were a part of a normal distribution.
All right, let's do that last piece. Now we'll save this one. But what? See, this is what happens with you. We're done with. Okay, so I think here we go. All right, so if you go back to your fit x by y, the big class, there's our good p-value, right? And we want to click on this, the linear fit triangle here, and save or plot residuals right there. Okay, and then it should give you little diagnosis plots of the residuals, which is, and the residuals are how, so like the residuals are how far off the observations are from the line. Like this one is almost zero because it's on the line, and the same with this one, but that's a very big residual, the same with this one. So the ones that are farther away are bigger residuals. And the whole point of this modeling aspect is to minimize those. So if you can get the smallest residuals that the points closer to the line, that's the best. But you want to look at some of the properties. So this is residuals by predicted. And so what you want is the weight of the residual and the weight of the predicted to follow somewhat of a, you don't want there to be like a clear correlation here, which there isn't. So if you saw like that there was some, the predicted and the residual were correlated, that would mean something is wrong with the model, and like you're something in here is predicting the error that's not just random chance. And so what you want the residuals to be is just like things you couldn't explain. Now there's things that are being explained that are correlated, then something's wrong with the way the model is set up. But what you want for this first plot is to see no correlation, which you do, right? So it's pretty clear that it's just like a scatter plot. You might want them to be more, dispersed throughout, like there's a big bunch in the middle here, but I think that's okay. And then this one is weight actual and weight predicted. So this looks like there's a pretty good correlation, which is what you want here, because you want the predicted to be close to the actual. So it's a little bit different where you're looking at all these different diagnostics. In this one, you want the residuals to be around an average of 0. So see how they're kind of up and down above 0. And if they're like way a bunch down here or way a bunch up here, then there's some unexplained thing going on. And so on. And then this normal one is showing that they're, within some normal distribution. But if you look, there's like 1 or 2 that are kind of outside. It's all usually up. Mary and Alfred are kind of on the borderline of not being in a normal distribution, but these are just different ways to look at, and if you see some, clear patterns that shouldn't, like, if all the dots here are like outside of this ellipsis, if the residuals are mostly above or mostly below 0, and if there's things that just don't look like they should, that would mean that there's something wrong with the model set up, but it's not just random error, it's some other thing you missed. And there's a few properties that we'll just confirm on the residuals when we do the write-up, but it's a pretty good just rule of thumb just to look at the plots and see if anything looks out of place. Okay. Questions on residuals? Okay. Yeah, I mean, most of the time in this class, you're just taking a visual look. There's not, because these data sets are provided to you, there's only 1 or 2 cases where you're going to actually get your own data. If the residuals are off or something is, not the way it should be, it's just important to note it, but because you're not really doing like a lot of gathering of data, there's not much you can do about it, but it's still important to know, like, if you're doing analysis for, a big project or for your job, that if there are things you can do to fix it, then this is one of the ways to, diagnose the issues. Okay, so why don't we, I think we've completed this exercise, so why don't we save this one? And this is the big class fit X by Y. Oh, everything is on here, I think. If we do the very top triangle, open it, save script to data table. You can leave this as the default if you want. And to close that. And then I think, I don't know this one has a bunch of other pre-down stuff to it, right? Where's the one we just, this one? Yeah, okay. It looks like this one came with some original analysis, but I think the one you saved should be the one at the bottom there. So it's okay, and then we can file, save as and save as big class and then put my initials like last time. Okay, and again, if you close this one and open it back up, it should be just where you left off, if you save it. And then this one. Maybe I put. All right, back to the detail page. Where are we at? Okay, so I think we've done number 2 as well. So if you save your scripts and the JMP document with your initials, you can also post that one with your other one here. Yeah. Okay. So that can go there. Let's see. All right, how are we doing on? This class goes to 11:45. Okay. Why don't we, should we take a 5-minute break and then, you're only about another, let's take a 5-minute break and then we'll do like another 30 minutes to wrap it up. So let's meet back, let's come back at 11 and then we'll do 30 more minutes and we'll finish up with it. So, all right, good stuff. You see the TV remote? Oh. There we go.
Shane.
Oh,
Um,
nice to meet you.
Nice to meet you. Is there any way I can leave, just leave now, because I have a wedding to get to.
Sure.
Yeah.
Yeah.
Sure.
If you got a wedding, yeah, I'll attempt to post the recording so you can catch up, but yeah, no problem.
Thanks a lot.
Yeah.
Hey, just letting you know too, Professor, I think I figured out the JMP situation. I think I just have to update my software on my computer and I should be able to download it after that. So I'll do it once class is done.
Oh, good. Yeah, excellent. Thank you. Okay. All right, I think everyone's might have leave for a wedding, but everyone else is back. Um, why don't we start with the next example, and we might not finish it, but that's okay. So for the week one study guide, we've gone through all the key concepts. We watched 2 of the videos except for the one. You can take a look at that one. We've done examples for questions 1 and 2. We have a few more to do. Questions 3 and 4 just require you to upload a data set that I provided. So why don't we have some practice with that, and then we'll do some interpretations as well. So for number 3, let's open the Excel golf club demand one that I have in the website, and let's do a simple linear regression. So this is a sample of clubhouse data, and we're going to estimate the linear effect of the price of golf clubs in US dollars on the demand for golf club set. So price is our X variable, and demand or quantity of golf clubs is the Y variable. Okay, so we have 12 months of data. Like it says here, demand is the Y variable, price is the X variable, and what is the linear effect of price on demand? So we're essentially going to repeat this type of analysis with a different data set. So if you go to, let's see, back to week 1, and there should be a golf club demand data set here. All right, and you click on the arrow and download it. Okay. So that should go to your download section or wherever it goes default. And then what we're going to do is open up JMP and then import that data set. All right. So if we go to just the general JMP homepage, and I think if we do file, open, mine's went to downloads. And make sure that the type of is all files, because it's gonna find the Excel file. So if it says just JMP or something, make sure it says all here. And then it should be wherever you just downloaded it. Click on it and hit open. Okay, so it should take you to this little Excel import wizard. So any issues getting here? Good. Okay. Now I did notice that this one had like, oh no, this one looks fine. Okay. All right. So just here's a preview. You can see like there's 12 months of data. This is the price in dollars for a golf club set, and this is the quantity of golf club sets sold. These are just defaults. They should be fine, but you don't need to change anything unless you see something that doesn't look like the Excel document, but just leave all the defaults and hit import. And then it should put it into a JMP data set just like this. Yeah. Okay. So we've got just 12 months of data. Here's the price. Here's the demand. And we're going to estimate the effect of price on demand, or a demand curve essentially. So when the price goes up or down, what happens to demand? We're assuming that when the price goes up, demand goes down and vice versa, right? It's more expensive, less people can buy and afford it, and the opposite. So why don't we do the analysis we did with the previous one? Let's do analyze, fit X by Y. Okay, so what do we want to put as the Y variable? Demand, right? Okay, and then we want to put price as the X variable, right? And month is just the indicator. You don't need to put that into the model. So demand is Y. X factor is price. We'll do the same, linear regression and hit OK. And it should look something like this. So this is, just a general demand curve. We can see that when the price of these clubs goes up, less people buy it and vice versa. We don't know the exact relationship, but it's pretty clear that more expensive clubs have less demand. And that's because, the individuals on the margin don't buy it, or they buy less, or what have you. Okay. So now we're going to do, click on this triangle. And let's do fit line. Okay. So and we'll write these down in a second, but the main things that we learned so far are these here. Okay, so we should be able to look at the regression equation, the R squared, the coefficients, the p-value, and we'll plot the residuals. So why don't we do that? Okay. So here's the equation, right? Demand equals some constant, and then this is the effect of price on demand, just like last time. This is the Y variable, this is an X variable, it's just different concept. All right, and it's a pretty good fit. It's not perfect, but well, actually it's a pretty good fit. It's R squared is pretty high, but and most of the points are pretty close to this estimated line. There's a couple, outlier kind of things, but for the most part, it seems like a pretty good fit of price on demand. So first thing is, what does this -35 coefficient mean?
Every dollar they increase the price, they use the million about 35.
Yeah, that's exactly right. Yeah, that's exactly what you said. So this we know you looked and saw the prices in dollars, and the demand is golf club sets or golf club units, and we know that if price goes up by 1, which is $1, this is the effect on demand. So every time the price goes up by $1, we lose about 35 cents, right? And vice versa, if you drop the price, then you expect to sell about 35 more. And obviously it's an estimate, you can't have 0.46 of a golf club set, but it's approximately 35. Okay. What about the R squared? So what is that? Well, let's just look at the adjusted. So it's about 0.89 or so what does the 0.89 mean? Based on what we learned. All right, so a scale of 0 to 1.
It's a pretty good model.
Yeah, that's in summary, yeah, it's a pretty good model that the scale that individual presented, but remember this is the percent of explained variation in the y variable, which is golf club demand. So it looks like we explained about 90% just by looking at the price. So which makes a lot of sense, like the number one predictor for what is sold and what is demanded is the price of it, right? Yeah.
So it's like, depending on which means R squared adjusted, like 89 or 90% of the increase in demand from the increase in price. Or like $1 increase.
Not so much, that interpretation is more for the coefficient. This is just telling us on a scale of 0 to 100, how much did price alone explain demand, right? So if we're just trying to predict demand, and if we use only price and nothing else, then we explain about 90%, which is pretty good, right? There's probably some other things like location or brand or what season, yeah, that's right. It's that. Right. So I'm not much of a golfer myself, but I am an economist, and I could probably confirm that the price of the golf club is one of the number one things of how much is sold. Okay, and then look at our p-value. It's super low, right? It's 0.0001. It's got a star. We're actually like over almost 99% confident this is the true case, but you're looking for this to be less than 0.01. It's way less than that. So we're pretty confident that this is an average relationship, and that when the price of these clubs goes up or down, we expect this to be the average effect occurring. Okay, last thing we had to look at was click on linear fit and say, or plot residual, right? Okay, so the first one, it's like a bit of you want these things to be around 0 or around no correlation. You want these to be close to the red line. You want these, this actually there's a little bit of you'd want this to be a little more, actually, because there's only 12 observations, so it's probably fine. It's around 0. This one, you would want your observations to be a little more balanced. In this case, they're more on the negative end. It's probably fine. It wouldn't, indicate too much, but if you did a bigger sample of like 5 years and you saw, essentially like 80% of your observations be below this line, that might be an issue. But in this case, it's such a small sample that, the p-value is good. I wouldn't worry too much about it, but it just something to look at when you see like an anomaly like that. Okay. All right, why don't we save this one? This little red triangle. Save script to data table. Fit y by x, demand by price is okay. It should be here now, right? There it is. And then make sure you save your whole JMP data set. File, save as. Downloads, I want it here. My initials. So this one, there are a few more follow-up questions. This is. Okay, so we're still in number 3, and this one asks for the scripts and the JMP file and then an interpretation. And so let me give you just a quick kind of bullet point or roadmap of how the interpretation would be. It's basically what we did verbally, but how to document it. So I have an example here. Let's see. One of these I like better than the other. Yeah, this, okay. So question 1 is ignore that because that's the one I couldn't find. And here's the one we just did. So let's focus on. So this is the same question, right? We did the estimate. What's the linear effect of price on demand? And so what I want you to do for documentation purposes, you can use this example here for this one, but you want to write out the equation, and it's usually given to you in JMP. So demand is a function of some intercept, 21,000, and then minus that coefficient that you interpreted. You could probably just, let me see where, you could probably copy and paste it from JMP. Let me confirm that for you.
Would you mind uploading the example?
Yeah, I can do that. So if we go back here, here's our, yeah, I think JMP has got some nice features, like you can select this. And if I Control C, I can probably copy it. Yeah, okay. And then just understanding what that equation is, but if you were showing the simple regression equation, that's what it would be. Demand is a function of some intercept, and then, you know, that every time price goes up by $1, this is the effect on demand. Okay, then a quick interpretation of the R squared. The R squared was about, it was 0.9, right, from there. And so that means that approximately 90% of the variation in demand, the Y variable is explained, right? Okay, then importantly, what does the coefficient mean? Exactly like we've interpreted in class with the actual metrics. So here's the coefficient, negative 35.46. When price increases by $1, right, the effect on demand is a decrease in 35 units. All right, so knowing exactly what this means with the appropriate metrics is one of the most important things. So price goes up by 1, which is $1. The demand goes down by 35, which is 35 units. Okay. The p-value. The p-value is negative. I think you can also copy and paste this from JMP if you like. Let's see. Here it is, right? It's this one. Maybe you can't copy and paste that one, but it's less than 0.0001 is what it says, right? Okay. So that tells you that we're significant at the 99% level, because if it was 0.05, that was the 95%, and then anything below 0.01 would be 99% level. So we're far below that, right? We're pretty confident this is the average effect. And so again, as long as this p-value is less than 0.05, you can be pretty confident in the results. So this is the threshold. And if we looked at that one, there was a really bad model, it was like 0.3 or something. Okay. So then there's some criterion for the residuals that are just, it makes a good documentation just to note what you saw. And so you're looking for normal distribution of the residuals. You're looking for a zero mean, and you're looking for they're not correlated with each other. All right, so normal distribution can be satisfied by looking at this. And I would say, like, when you're writing a statement on the residuals, just write this statement, but make sure you confirm it holds. Like there might be some cases where there isn't a zero mean or something, but you can start with this benchmark and then just make sure you check that the check marks are confirmed. So let's look for this one, normal distribution. So here's the normal residual normal quantile plot. So what this means is as long as the residuals are within these bounds, it's a normal distribution, right? So nothing is outside these parameters, right? So we're good on that one. That's a check. Is there a zero mean? So we can look at this one here. Okay, so the zero mean one, you can look at either of these residual by row plot, or actually all of them, all the ones except for this one that show that the expectation that it's what you're looking for. See how it's like negative 500 and this is zero. You want the residuals to on average be zero in this plot, and this plot, and this plot. It's pretty close. Like that one looks fine. That one looks fine. Like I said, this one is a little skewed towards the negative, but I think you can confirm this with the best practice, just saying like you looked at this plot, and this plot, and the residuals are pretty much like if the rule of thumb is if you took an average of all these, would they be about zero? And it seems like that's the case. All right, and then there's one more criteria, right? Not correlated with each other. So that can be confirmed by looking at this is by real number. This is the actual and the predicted, and this is the residual. These are kind of the same. Yeah, that one I would look more at this one. The very first one should show not much of a correlation, which it does, right? Like there's not what I mean is like if demand predicted goes up, is it clear that this goes up? And there's like a linear fit. It doesn't seem like there is. So for the most part, it looks good. Okay, so it's more of just a best practice to document, but just know that like in general stats or econometrics, you're assuming that the residuals follow a normal distribution. They have a zero mean, and they don't have a correlation with each other. So that's kind of the desired plots. You have to kind of assume those things are true if you're going to go with the interpretation of the model. So like this section here, with the simple regression, the R squared, the coefficients, the p-value, the residuals, this is like it's a pretty simple bullet point interpretation, but that's like the full 1, 2, 3, 4, 5 interpretation of the example. And I'll post this for you to use, but. Any questions on those items? Okay, and things might change a bit when we do different models, but for these ones, that's the gist of it. Okay. So. Let's. Okay, so essentially, and then, so for the first assignment here, so you have 4 different, JMP documents for each example, and then if you want to just post one word, or if you want to do a PDF, whatever's easier, to the homework section showing the interpretation. So you're gonna post at the end 4 JMP files and then 1 PDF of Word interpretation. And then I'll leave the last one for you to try to do on your own, but it's pretty similar to what we just did. So you're gonna open up this example, or you're gonna download it, the exponential growth. You're gonna import it into JMP. Okay, and then you're going to look at and note that this one is, the only difference is the y variable or the x variable is a time variable, so you're looking at the effect of time going up or down. So here we have exponential growth, and we're gonna do a simple linear regression. And for a hypothetical company, you're gonna look at the historical sales of potato chips over the 10-year period. And then sales is your y variable, and year is your x variable. So all you're gonna do is look at the linear change in sales each year. And so you're gonna repeat the same analysis, and then interpret it based on the other example. So let me just make sure that this one imports okay, and then I think you can do the rest on your own. So if you want to do exponential growth and download it under week 1, and then go to your developers. Go to JMP and do file, open, downloads, exponential growth, open. Yeah, it looks fine. For some reason, one of them was having some weird, like, bullet points when I did it at home, but it looks fine now. So if you just do the regular import, it should be good. Okay. So this one, do the same analysis. We've done like 3 times or 4 times, and you're gonna look at the effect of year on sales. So just make a observation that year is your x variable, sales is your y variable. So it's not like, it's not price or height or whatever. It's when year, like each year or so on. So just when you make your interpretation, year is changing by 1, and sales is changing by whatever dollar value. Okay, and then you can just do the example. All right, and then all you have to do is, for this one, save the scripts on the JMP file and do the interpretation, just like this one, but it's a little bit different, but the same process. So, I'm good. Yeah. Yes.
To save all the scripts and JMP files we just did, like JMP file, you just go to the file and then do the save session script, or is it already like saved on there?
So let's see. So like this one. You would do, so after you say this, I'll do the one we already did. Okay, so here's the one. All right, so you did the fit X by Y, right? And you do right here, triangle, save script, today's table, right?
Yeah, so like, I get that part, but
Okay.
like, once we already do that, was it already just gonna stay there, not like save it then?
No, so yeah, so you save it there, it stays there, and then once you save the JMP one, right, so if you close it, and you save it, if you try to open it up again, like this one, it should just be there.
Okay, and that's already the one you just open right now, that's just gonna stay there, right? When we open it.
Yep,
Okay,
correct.
that's what I was.
Yeah, no, that's good, yeah. All right, so we can start wrapping it up here. It's about 11:30. And then depending on, it seems like we're pretty good on the JMP, so I'll go ahead and leave, sorry, this is the solutions. All right. Oops. Yeah, I'll go ahead and leave the due date as next Saturday. If there's any technical reasons, you can have a short extension, but we've already done, 2/3 of it or so, or 3/4 of it, I guess. So there shouldn't be any problem, just put your 4 JMP files and the one word interpretation up there. And just sometime by next Saturday. If you have any questions or have issues with number 4, you can let me know, or I can, I try to do the due date later, because if there are any final questions, I can address those next time and just give you some time before it's due. But yeah, I think that's a good start for today. Next time, we'll probably look at some multiple regression stuff, add some more variables, rather than just like the 1x and go take the next step. But I think this is a good starting point. Any final thoughts, questions?
The paper you were putting your answers on, was that something you just created from scratch, or was that a file on the Brightspace?
Yeah, I just created it with a blank Word document. I'll post that one example we did together so you can use it, but yeah, I recommend just opening up a blank Word document and just doing the same process.
Okay, sounds good. And then are you gonna upload today's lecture? Because I think I'm gonna have to follow along again once I download JMP.
Yeah, like I said, I'm recording. I'm assuming there's not gonna be any technical issues, but my plan is to upload this recording to, I have like a ULB YouTube area just for my class recordings. So I should be able to put it there, and I'll send you all the link or put it on the webpage. Assuming I don't have any issues with doing that this week, but it should be available like today or tomorrow.
Okay, thank you.
And you have a question?
Yeah, 3 and 4 were the only ones we have to do in Word document, or is it all 4?
Oh yeah, just 3 and 4, because the other ones were pretty simple and we're doing that was just to get it started. So yeah, just the JMP files for the first 2, and then interpret 2 and 4, or 3 and 4. Okay,
I have a question about interpreting the results.
yeah.
So you showed us what, like with the R, and what the values were. Do you want us to make a separate paragraph of us explaining what the results were and what they mean, or is it just the facts that we saw on the script? Just the numbers.
Let me.
Thank you, Professor.
Oh, thank you. Yeah, you too. So you mean these ones here?
Yeah, is that all you're expecting, or do you want us to add something else to that?
Yeah, that's it. Just these 5 sections. Just yeah. So all I have to do is write out the equation, interpret the R squared, interpret the coefficient, the p-value, and the and check for the residuals.
Okay, cool. Sounds good.
Okay,
All right. Thank you so much, Professor. Have a good one.
you too, you too. All right, it's good. All right, I'm gonna go ahead and end the recording and I'll see you all next week. What do we put in? But